Hello, everyone, and welcome to Agulhas Current Affairs, a marine science podcast set in Southern Africa. With me as one of your hosts, Dr. Jens Kirsten of Geekoscopy Media, alongside
Dr. Nelson Miranda of Argonaut Science. And today we're talking about science, we're communicating about science, we're talking about science. It's going to be a fun time for us.
Yeah, so we are specifically talking about science communication. We mentioned on our last podcast about Beyonce that at the latest conference there was a kind of call for more storytelling in science so that researchers can convey their story to the general public as to what's going on in the natural world. And it is kind of already weird because this podcast is a form of science communication, so we'll probably discuss a bit of that as we're going on. But that's kind of like the whole point, because communication just means like interacting with another person, kind of like telling them something or having a conversation.
I send a message, I'm the sender, you're the receiver. I send a message, you receive the message, you let me know you've received the message and what it is, and that's communication, right?
Yeah, 100%. So there's different forms of how human beings can communicate, and different forms of how science can be communicated as well. I think sometimes when a scientist or a person might hear the term science communication, they might think, oh, just like social media, just like blog. But those are like drops in the ocean, essentially. Okay, the ocean is big, but those are like very specific forms of science communication. And technically, a journal article is also a form of science communication. It's just that it is communicating to other people who are also scientists or in that field, so that they can understand what you're doing with your work. And that's where it kind of like starts. That's the first form of science communication. And speaking to each other, having discussions, it's a very human thing. It does happen with other species, but I think it is such a fundamental part of being a human being. It is one of those I don't remember if you've seen that experiment with the chimpanzee that kind of presses the buttons, the numbers quickly on a touchpad.
Right.
And like if you try and do that, you wouldn't be able to. Like if you just saw like a picture and try and remember, like, and the picture goes away, try and remember where the ones and twos are, it's not something you'll be able to do. But something like a chimpanzee, which is only 2% removed from what we are genetically, like we can't do that. And like you wonder why. It's because a lot of our brain power is being used by language, being able to communicate with each other in a very detailed manner. And one of the things that we communicate to each other is stories, because we try and internally try and create a story that we can tell another individual, so we can explain to them something. So we tell a story about how, like, if you go into that cave, a bear is going to maul you because I went there earlier and almost died, so please don't go there. And this kind of explanation of our environment and our lived experiences enabled us to like come together and work together and also pass stories down generationally, like at the campfire. And this is where like the archetypes of like elders come in, who have lived for long and have a lot of stories so they can tell the young ones. So I think it's a very fundamental thing about human beings.
Absolutely.
A lot of people have proposed that we actually at a definition level are just a species that storytells.
We're absolutely a storytelling species. Like the very particular way in which we tell stories is very human. That's part of what makes us human. So I love that. I think it's a great story to tell. Even that.
Even that, yeah. And we'll get into some of that. So why would we want to communicate science? Like it's one of those things where, I think if you talk to any like career scientists, like they've got like no time at all. You were telling me earlier about this chapter you have to write, and it's like,
No one has
where are you
time.
going to find the time?
No one has time to do any work
it.
in science. We're all too busy.
Exactly. Yeah. Too busy actually writing the paper or doing other things. But this is a fundamentally important thing because of the things I mentioned earlier, where that some of these work that you're doing does have big impacts on people, and they need to know it in order to make decisions about their life. So in science communication studies, there's a model called, which is very easy to remember, the AEIOU vowel model. And the A stands for awareness. So we need people to be familiar with some aspects of what scientists are doing. E for enjoyment. So the thing that they are interacting with, whether it's just having a conversation or a written piece or a video or a game, needs to be enjoyable in some manner, so that people just don't just like leave.
Yeah, it needs to elicit an emotion as well. I think the E could also be emotional,
I think that's a good one. That's a good one. We need to rewrite this paper, Nelson. We'll put our E for emotion there. I for interest. So obviously, only people who are interested in that topic are going to be able to stay there and pay attention or listen to what anybody is communicating. O is for opinions. So try and, if it is important enough, change people's opinion as to what certain things mean. Or the way that they act in their lives. And U is for understanding. So try and broadening the understanding of, firstly, what is science and how does it work, and kind of the outputs of science and the conclusions we come to, and how that affects everyday life. Is this something new to you, Nelson? Or have you heard of the AA?
Yeah, I have not heard of this before. This is, this is new to me. It's a very nice way to remember, the broad range of the purpose of science communication. And I like each of the letters. Opinions, it's triggered something in me. It's like we all have our opinions, isn't it? And even scientists, even though we get very emotionally attached to our work because it's backed up by observations. There's that O again, observation and opinion. So we also need to realize that at the end of the day, these are our opinions. Really, because they are the fact-based opinions of someone, that is maybe a professional opinion, but it's still an opinion, like we all have opinions. And at the end of the day, you need to understand that as well, isn't it?
For sure, definitely. And it's we mentioned a few times in this podcast about perspective and how that can change. Like your lived experience can highly influence how your perspective about certain things can be. And obviously, like a lot of scientists, their perspective is just like, it's the numbers, it's what's published, it's what's been reviewed.
Yeah.
And the upside to that is that we can change our opinions based on new evidence.
Yeah, we should. Not only can we, but it's a very important function of being a scientist, that if the numbers change and if the evidence shifts so that the opinion is not upheld, then there's no choice, the correct choice. Actually, there are many choices, of course, but the correct choice and the professionally correct choice as a scientist is to change the opinion immediately. That's the whole tenet of observation and evidence.
Yeah, for sure, 100%. Although it doesn't foolproof the kind of situation whatsoever. Yep. At the end of the day, I remember I think I don't know if I told the story on this podcast, but I'm sure you remember Taro Mbera.
Yeah.
Mobvu from UK.
Yeah. Love the pop. Taro, if you hear us, if you're out there, I miss you, man, and I miss our pop. We have pop for breakfast, we have pop for dessert. It was awesome. Anyway, carry on.
Yeah, it was really, really great lecture, top tier. But I remember sitting in such a vivid memory. It's like a core memory that I have of the second year, I think, practical. And I was asking him, like, why do like certain scientists have like different opinions, or why is this scientist like doing this even though like we know this? And he was like, at the end of the day, scientists are people
Yeah.
first. They're not this like machine that acts in a different way. They're still human beings.
Oh yeah.
They're still human beings with that storytelling in them, and they've obviously had this perspective. They told themselves the story about how the world needs to be, and they've accumulated enough evidence in order to stick to
Yeah.
that, and they stay that way, even if sometimes new evidence is
Even if it
is not
is, and that's the history of science, even at the macro level. So groups of scientists have always been a little bit resistant to change. And if there's some evidence that mounts against the first worldview, then you tweak it, isn't it? You tweak it, you don't change it. And it's only after a lot of effort and a lot of evidence that things may actually change at the different scales. But yeah, we are all human, we are all fallible, we are all prone to bias, and that is important to acknowledge as a scientist.
Sure, 100%. And coming back to communication, so like we said earlier, that like scientific paper that goes through like the scientific method and goes through the review process,
Yeah.
where your peers kind of like look at it and like sign off on it and like correct it. That's the first step in
Yeah.
science communication. Actually, technically, it isn't the first step, but it's the first like output.
Yeah, it's an important output, right? It's an important output, and it's become quite an indication of productivity. Publish or perish. That sort of thing, and it is definitely a high quality peer reviewed. That's why it's peer reviewed, to maintain high standards of quality. Sort of product, and it's also referred to as white literature, I believe. Whereas, as opposed to gray literature, which is not necessarily peer reviewed, but it's also, possibly following some sort of scientific method. You know what I mean? Like reports and things like that, put together by professionals. That's gray literature.
Yeah.
But we're talking about like journals. Editors that call experts from around the world to review a particular piece of work, and that piece of work, after going through all of this grueling process and being improved and reviewed, then it comes out as a peer-reviewed scientific article, which is quite a thing. Quite a lot of effort goes into that, but it's not enough to tell the story to everyone, isn't it?
No, 100%. And I also want to point out that sometimes that isn't even the first piece of communication.
Absolutely.
In that, because it is the kind of the output in the scientific like method, but practically, like you're usually like working at a university or in a lab at a institution, and sometimes you have to ask for money in order to do like your research. So it's actually the first piece of communication is actually the proposal that you send to either a funding body or to your supervisor or whatever, explain to them what you want to do in the first place.
Absolutely.
The questions you want to answer.
Yeah.
So that's technically the first piece, but practically it is the scientific paper, and from that point, then is when we need to begin translating it for other niches, because now that paper is for that niche of other scientists in their field generally, or other scientists, and it's going to be full of technical writing, it's going to be full of jargon, it's going to be difficult to understand. If you don't understand how papers are written and why they're written a certain way, then you might not kind of get it. Or if you just don't know certain terminology, you can understand.
Yeah.
So at that point, it needs to be translated by somebody. Sometimes it could be the scientist, but by somebody, so that the layman, the person in the street, average Joe, can then understand what the scientist probably spent 2 years in a lab trying to work up.
Yeah, and also people of different ages as well need to understand. And this is where something very interesting may happen. So we're generalizing about journals, but there are some journals that are in fact edited by children, by young, people.
By children.
So,
Yeah,
so,
yeah.
so that the work, it has to be rewritten in a language that is understandable, by children, or a simple language that actually is understandable by everyone. I'm actually a big fan of this, and one such journal is the Frontiers journal, Frontiers for Young Minds, which you can check out the link in the description as well.
Yeah. 100%. I'll link it in the description. And that's another niche. Even though it's done in a similar way, it is a peer review, I suppose.
Yeah, it is.
But obviously, that is being geared towards children being able to kind of get
Yeah,
it,
and
because the children are like editing.
it's a rewrite of research that has been published in another form. So it's really cool in that sense, in that you're not really changing the quality of the research. You're just changing the way in which you're communicating, and you're ensuring the communication by having a peer review panel composed of the audience that the kind of age group that you might be targeting. In fact, But I find that reading these papers is a very useful, for teachers as well, and also even just general public. Sometimes reading these papers in like simple language is helpful to try and understand some of these concepts.
Yeah, even though like technically, it's impossible to like communicate to everybody. Some pieces would work. But I think when it comes to just the human experience, people are like so different. And like you said, there's different ages, different walks of life. So knowing who your audience is and writing or communicating for them is kind of like a fundamental problem in communication in general. But also if you're a science communicator, if you want your knowledge to be spread, putting it in ways that can be understood by a wide range of people, because generally one piece of work is not going to work for everybody.
Yeah.
And generally, like, even if you try your hardest, everybody's not going to like it or even be interested whatsoever.
There's language barriers as well, and maybe, and this is like quite an important thing, maybe you want to communicate to the people in the area where you've done the research. This is quite an important thing to consider, and there's definitely a lot of work happening in Africa and in our region, where science communication is crucial, because the work has to go back to, for example, indigenous peoples in the areas where the research is happening, and it has to be communicated in ways that are understandable to indigenous people. So even the media in which you communicate may not be the written media, for example. So that's also a very important part of science communication.
Yeah, and there are different ways to translate things. There are different ways of involvement of who you're trying to pass the knowledge towards, because a scientific paper is generally like a one-way communication, right? Somebody writes it and another person reads it, and we call that like the dissemination / the deficit model, right? It's just a one-way communication.
Yeah, it tends to be that way.
There are other ways to communicate. Yeah, there are other ways to communicate, including having conversations with people. So like one end of the spectrum is deficit dissemination, and the other end is an engagement where you want to get everybody involved and have a conversation about what's going on, instead of just like lecturing to them, which can be, I think that's probably the most common form, the deficit model or this dissemination model. But I think doing it in every way that you can is important, especially for things that affects people on a fundamental level, like their livelihoods and stuff. That's why when government needs to change some kind of policy, they usually have these like town halls and like get stakeholders together and kind of discuss it. So that's on the other end of engagement and science communication. Is that when you have everybody together in a room, kind of like talking with each other and coming to some kind of conclusion, Won't get into too much details about the other ways because it's a lot of unnecessary information.
Yeah, it's a lot of information.
But if you're a scientist and you're trying to disseminate that information, that's what we usually call science outreach. So if a scientist or a department or university is kind of like having a program where they want to disseminate information, that's usually referred to as outreach. But if you, instead of doing that, what can also happen is that if it's work that's interesting to mass market to the general public, sometimes they can kind of outsource that communication by getting reporters involved or calling up a journalist. Usually it's a journalist that's well versed in science communication or writing for science, and you ask them to, okay, I need a story written. We found this thing out. You need to package it in a way that your readers and or listeners, audience, can be able to get it. And if it's a thing that the audience is going to be interested in, then that journalist will then go on to write a piece or create a new story so that it can be communicated to people. So we call that science journalism because there are different ways to package these things. And like we said earlier, it can overlap. But when we talk about science journalism, that's what's happening. It's the mass media that's repackaging the information. The pro is that it's probably going to be seen by a lot of people. The cons are usually that it's very like tiny segments. Sometimes it can be
it's
like
out
a
of context.
Sometimes,
Context is a major issue. Sometimes the scientist doesn't get to view the piece that's being aired. So, and the scientist said, "Wait, that's not what I meant to say." The scientist sometimes doesn't have impact, a way to edit it, because again, it's journalism, so it's catering for a different sort of market and a different sort of audience demand. Maybe people want to see like a dramatic story, and then the scientist, well, it's not dramatic, but then the journalist will say, but it is, right? So, so there's like sometimes these clashes in communication between the journalists and scientists. But at the end of the day, we just need to be clear on what we want to say as the originator or the talent, as they would call, of the story, just say that in as clear as possible, as directly as possible, just be a little bit assertive. If you ever been in a situation where a journalist wants to get the drama out of you.
yeah. Because they are on the story end of it, right? So like the science is going to be on the like more the reality, the numbers end, and the journalist is going to be like, oh, like I need to frame it into a story that my listeners are going to be interested in.
Yes, it's about interest. It's about capturing the audience. It's about having the audience coming back and consuming that particular type of media. So to be fair, like that's if you understand what the different people want in that communication, then it's easier to sort of negotiate and have something that both parties will be more or less happy with.
Yeah, for sure, 100%. So and everything else that's being communicated usually falls into the broad bracket of science communication, which mostly is run by communication professionals. So it's people who are well versed in whatever way of communicating that they've learned to do or practiced over a long period of time, and they've either built an audience or they're good enough to be hired by companies in order to do that communication. So that can range anything from like a wildlife documentary, like that's big budget and you have like film crew, all the way down to just somebody who's like tweeting about things.
Yeah.
So it includes everything. So like podcasters, YouTubers, like what we're doing right now, that falls under it.
Yeah. We also happen to be, we also happen to be consultants, isn't it?
Yeah.
So we're communication experts in a very specific field, like the scientific field, and we do consulting to that end. So we assist, and maybe we can be, because they're also known as catalysts, isn't it? So we can help to bridge gaps and to bring together different kinds of communication, and to make everything work optimally. So we can really be a very valuable resource as part of a team that aims to communicate science.
Another type of kind of box or profession that you might hear is a science writer. And that kind of can include all three of those things, technically. But anything that is not a written piece of science, the publication, journal, article, or a mass media written article, like in a newspaper, that technically falls under science writings. But the broad general idea of those pieces are either like blogs, or sometimes like medical stories, sometimes just technical like reports and things like that. So anything else that is not a journal article or is not a newspaper article generally falls under science writing. So they're not really journalists. They can be scientists, they can be journalists, and they are science communicators.
Yeah.
But if you do hear the term science writing, that's what that refers to. So obviously writing is a form of media that we've mentioned multiple times here. It's probably one of the earliest forms of mass media, going all the way back to the Gutenberg Bible, the first one. But nowadays, technology has advanced, and there's a lot of different ways to communicate your ideas other than just like speaking. So what are the different types of formats you can throw out there?
Oh, wow. I mean, because science communication can also be art. And that just opens up everything. I mean, we should be collaborating with artists as scientists and vice versa. And even it cuts across the different kinds of science, which include the social sciences, the natural sciences, right? The hard sciences and the soft sciences, I guess. So that means that we could make an art piece, it could be a song, it could be a painting, it could be, there is infographics, that's very popular. So visual media, is very popular. Audio media, it could be a film, right? So that's really cool. And I mean, I love like what filmmakers are doing, and I love the idea, I mean, the potential of African storytellers as filmmakers. And this is why I also have to mention an organization that I've been working with this year, NEWF, the Nature, Environment, Wildlife Filmmakers. And they are wonderful because they provide opportunities for young scientists and storytellers to work together and tell stories, from Africa. So I really think that's a great initiative, and you'll see that they are on the up, they're on the rise, and you'll already find very, very great pieces of work from wonderful people, films, so that's a really powerful media. So songs as well, I mean, we love our science songs. We have a chuckle every time we think about different songs, and we use those, and they appear in movies as well, which is really cool. So those are whatever you can sense can be a form of communication.
And I think going back to the fundamental thing of storytelling as humans, even though this is now probably the most like expensive and the most like time consuming or most logistical way of outreach, is usually having an event where people come together so they can physically interact with people and or the science, museum exhibits and open days at science. Stakeholder meetings also technically count. So those events, those public engagement events, kind of bringing people together so they can physically be there, and maybe have potentially more tactile experience or more conversational experience. That's what you get on the total opposite end of the science paper
Yeah.
is these engagement events that science departments, universities can throw, non-profits, government organizations. There has to be a will to do this, so that things can.
Yeah, events are super important though, and I think it's so interesting because they can actually contribute to the science itself. So if you include an event about science and then there's a citizen science element to it, it can actually feed back into the actual research, which is crazy. This is why it might be a little bit confusing, and there's lots of overlaps because it's like a network, and the synapses are firing in all directions, and that's the power of science communication, isn't it?
100%. And like you mentioned, once we get to that opposite end, if we dip, it kind of like comes back around.
Yeah.
So the public was actually getting involved in the science. That's what we call citizen science.
Yeah.
Which you do a lot of work in that space, Nelson.
Yeah, and I think it's a really powerful way and a really important way to engage, you could add an element of citizen science to your project, potentially as a scientist. So something to consider, definitely. It will help you engage with, if you're working in an area, with the people of that area, depending on what the subject of your research is, of course. But yeah, you can do science about everything, isn't it? You can science everything.
Yeah. Including science communication.
That's right. So just like you can write an article about another article, and then you can write another article about that one, you can also do research on the writings about research. So
100%.
And that's like
so science communication studies is part of social science.
Yeah.
So there are social scientists who study human behavior and try and figure out are these things that we are trying to do to communicate science actually working?
Yeah.
How effective they are.
Yeah.
And then the science communicators that use that knowledge usually refer to it as evidence-based science communication.
Yeah.
So generally, I mean, there's different ways of learning how to do things. One of them is just like, I'm just gonna try it, like trial and error. Another is gonna be like in a professional sense where you study it. The downsides to studying it is that sometimes things get out of date pretty quickly. So either way, you're gonna have to learn on the job. And also sometimes you think that if you're trying something, it seems like it's working. But you don't actually know that it's working. There's no evidence. There might be a red herring somewhere that's kind of leading you astray. So I mean, that's why we do science in general. Figure out if these observations we make is it because what we think it is. Right? That's what hypotheses are on a basic level. So if you want to be more sure about scientifically whether your science communication is scientific and might scientifically work, then go read the Journal of Science Communication or something like that to figure out what the latest is and whether things are working. But yeah, so on this piece of science communication, we've come full center. The great inception has happened.
Yeah, it's
about
science communication, and then communication about science communication, and then science about communication about science communication. so yeah.
On this science communication podcast, which is about to end, and
Inception.
If you want to talk to us about science communication, and all the things we talked about, you can find this podcast at Agulhas Current on Twitter, at Agulhas Current Affairs on other social media platforms. I have a science communication media company called Geekoscopy Media. You can find me at Geekoscopy. And what about you, Nelson?
And you can find us at Argonaut Science, and our links will be in descriptions and all over the web. And yeah, this was great. I feel like we've covered a lot of communication based
Yeah.
Stuff.
Go communicate the science. That's the take-home meeting. The take-home message. All right,
Great.
cheers.
Cheers.